Good evening, everyone. So, in this session, we have to discuss some important question on Internet of Things. The first question is that digital twin and its use as use cases. Okay. So, what is digital twins? Okay. A digital twins is a virtual representation that is digital model. Okay. Of of an environment that is continuously update using real-time data from the sensor installed on a physical counterpart. Okay. So digital twin is a virtual representation that is in digital form of a physical object or process system or environment that is continuously updated using real-time data from the sensor installed on the physical counterpart. Okay, it enable the monitoring, simulation, prediction, and optimization of the real system. Okay, so what is the definition of the digital twin? So digital twin is a virtual representation in a digital form or the physical objected process system environment that is continuously updated using real-time data from the sensor installed on the physical counterpart. Okay, so it enable the monitoring things, simulation things, prediction, and optimization of the real system. Okay, okay. So important point to remember. The important point is real-time synchronization things. Real-time data synchronization. Sensor on the physical assets collect the data such as temperature, vibration, and motion, pressure, and status. Okay, this data is transmitted to the digital twins and keeping it updated. So real-time synchronization means that sensor on the physical asset sensor on the physical asset collects the data such as temperature, vibration, motion, and this pressure stats. Okay, this data is transmitted to the digital twins and keeping it updated continuously. Okay, they are transmitted digital twins and keeping it updated continuously. Okay, simulation and prediction. So digital twin allow the engineer or operator to simulate different scenario without affecting the actual system. So simulation prediction, in which digital twins allow to simulate different scenario without affecting the actual system. Okay, help in predicting the failure and understanding how a system behave under different condition. So simulation and prediction things is that a data twins allow engineers to simulate different scenario without affecting the actual system. Everything is okay. Okay, okay. Real-time data thing is sensor on the physical assets collect the data and information. This data is transmitted to digital twins and keeping them updated continuously. Okay, and the second part is that prediction and simulation. So digital twin allow the engineers to simulate different scenario without help the predicting the failure and the understanding how the system behave under the various condition. Okay, till here all thing okay. Life cycle management. So it cover it cover the entire life cycle. It covered the entire life cycle of asset, that is design, production, operation, and design, production, operation, maintenance, and retirement. Okay, and it help in optimization and performance and reducing the downtime. Enhance the decision making. Okay, digital twin convert the raw data into the actionable insights. Okay, it will convert the data into actionable insights. So enable better decision making using analytic machine visualization. Okay. Enhance the decision making. So it will convert the raw data into the actionable insights. Okay, okay, and after that integrated with the IoTs, cloud and AIs. So uses IoT, uses IoT sensor or real-time data. Okay, uses the IoTs and sensor or real-time data. Use cloud for the storage and processing, and use AI model for prediction. This one. So this one, these are. So use cases of digital twins. Okay, these are the important part. In important part, we have discussed that real-time data synchronization. So sensor physical assets, the physical assets collect the data as temperature, vibration, motion, pressure, and this data is transmitted to digital twins and keeping it updated continuously. Okay, simulation prediction means that a digital twin allow the engineers to simulate different scenario without it affecting the actual system. Okay, it help in predicting the failure and understanding how the system behave under different condition. Okay, life cycle management. So it cover the entire life cycle of the asset: design, production, operation, maintenance, thing. The production line using virtual simulation. So the production line using virtual simulation. So you use in the manufacturing process using smart cities, digital twin of traffic system, buildings, and energy consumption. Help to city plan, optimize route. Okay, and reduce the congestion and improve the utilities. Okay, and a digital twin of the traffic system. Okay, building energy consumption. Okay, helps city planner optimize routes. Okay, reduce congestion and improve the utilities. Okay, and healthcare, digital twin of a human organs like heart, personalized treatment planning, real-time data monitoring. All these things happen. Automotive and aerospace, simulate a vehicle or aircraft behavior. Testing performance under various conditions. Testing performance under various conditions. Improve safety and design efficiency. Okay, energy status. So monitoring wind, predicting the failure, and optimizing these things. So digital twin simply it is a virtual represent counterpart. It enable the monitoring, simulation, prediction, and the optimization of the real system. But the important thing: synchronization, simulation and prediction, life cycle management, enhanced decision making, integrated with the IoTs and clouds. Use cases in manufacturing area where monitoring the machine health, predicting the maintenance down, smart cities in the traffic system, building energy and consumption. So help to plan, organize route, reduce the congestion, and improve the utilities. Healthcare, a twin of the human organ, personalized treatment planning, real-time patient monitoring, automation, energy. So conclusion, digital twin combine IoT, AI, and data analytics to create a powerful virtual replica and improve the operation, reduce cost. Okay, and support smart decision making across the various industries. Okay, so second is of thing, problem it solve and solution it provide. Okay, wave of thing is an architecture that uses the web standards. The web of thing is an architecture that uses the web standard like HTTP, JSON, REST, and WebSocket to make IoT device interoperable, discoverable, and easy to integrate over the web. WOT focus on standardizing how IoT device communicate, not to the network layer itself. Okay, the problem IoT try to solve: lack of interoperability. Okay, IoT device use different protocol. Okay, MQTT, COAP, Zigbee, Bluetooth. Okay, so they cannot understand each other easily. Okay, lack of interoperability. Okay, vendor lock-in system. So device from different manufacturer do not follow a standard format. Okay, vendor lock system is device from the different manufacturer do not follow the standard format, and hard to integrate devices from the multiple branches. So hard to integrate the device from the multiple brands. Okay, complex device integration. Each IoT platform has different APIs. So each IoT platform has a different APIs. Developer need a custom code for the every devices, increase development time. So complex device integration. So each IoT. So the what problem solved by the WOT? First of all, there is a lack of interoperability, vendor lock-in, complex device integration. Okay, complex device integration. Okay, security and access issue. No uniform way to secure or access the IoT devices. Okay, no uniform way to no uniform way to secure the or access the IoT devices. So different device follow different authentication pattern. Okay, so solution provided by the WOT that okay, the JSON LD based document that describe a device properties or property in which read write action the operation event notification communication protocol like a detailed manual of a device. Okay, so solution is first a standardized thing description. Okay, uniform application interface, WOT abstract differences, and WOT abstract device differences using RESTful APIs. Okay, a device can access through different standard web method. Uniform application interface, WOT abstract difference using REST APIs. Okay, device can access through the different web method: get, post, put, delete. Okay, and after that after that protocol binding. So WOT work on the top of the IoT protocol. So WOT work on the top of the IoT protocol in which is MQTT, TCP, WebSocket, BLE. So convert them into the web friendly interface, solving the interoperability. Okay, protocol binding. Okay, protocol binding and easier mashup. Different IoT devices. Okay, different IoT devices can combine and control from the single web app. Okay, different IoT devices are combined and controlled by single app. Help to create a dashboard, automate automation system and the cloud IoT cloud platform. Okay, security model. WO2 introduce a standard authentication and authorization using OAuth2 JSON Web Token access control through the thing description. Okay, so first of all, understand the web of thing is an architecture that use the web standard HTTP, REST, JSON, REST, and to get to integrate over the web. WOT focus on standardizing how IoT device communicate with each other, not only in network layer. The problem IoT solve is lack of interoperability. IoT devices use different protocol MQTT and they cannot understand each other. Okay, vendor lock in device from different manufacturers do not follow the standard format and hard to integrate multiple brand. Okay, complex device integration. So each IoT platform has different API. Each IoT platform has a different APIs. Okay, developer need custom codes. Developer need custom code for every devices. Okay, security access, no uniform way to access the IoTs. Okay, the solution provided by the WOT, the solution provided by the web of thing is that A standardized thing description. Okay, a JSON LD based document that describe JSON LD based document that describe the property in which we have read and write action that have for operation, event notification, communication protocol, like digital manual for the device, like a digital manual for the devices. So uniform application interface. Okay, WOT abstract device WOT abstract device differences using the RESTful API. Okay, device can access through the standard web method that get post put these things. Protocol binding thing web WOT work on the top of IIT protocols like MQTT, COAP, HTTP WebSocket to convert them in a web friendly interface, solving the interoperability. Okay, easier mashup. Different IoT devices can combine and control from a single web app. Okay, help to create a dashboard, automation system, and IoT cloud operation platform. Security manual. IoT introduce a standardized authentication and authorization thing. Okay, so IoT provide a web-based framework that solve the interoperability, integration complexity, security issue in the IoT, and it enable easier for development of a scalable and secure cross-platform IoT. Okay, so the question is that Internet of Everything. Internet of Everything. Internet of Everything is and difference between IoTs. So Internet of Everything is the extension of IoT that connect people's process, data, and things to create an intelligent and interconnected system. IoE focus on generating a value and smart action from the all the connection. So IoE focus on generating the value and smart action from the connection. Cisco introduced IoE to show how connecting more element, not only device, create a smarter decision. Okay. Four pillar of IoE is that people a user who interact with device and data. Second, process the workflow or the logic that okay data the information collected from the sensor and analytics. And fourth one, things the physical devices, sensor, actuator, and machine. Okay, the four pillar: people, data, things, and process. Okay, these four elements work together to produce intelligent automation, insight, and the action. And how IoE work. So IoT connect all the things, but IoT connect things, human data, analytic, and process. Use cloud computing, big data, and AI and machine learning. Ensure the context-aware communication between multiple entities. Okay. Ensure the context. Ensure the context-aware communication between multiple entities. Enable the smart automation with the minimal human interaction. Okay. When we have to write the key differences between IoE and IoT, so focus focus basically IoT focus on connecting all the physical thing devices to the internet. Okay, so and in which the connect and extension, it is an extension of IoT, and in which the connection of people, process, data, and things happen. Scope narrow, only device to device communication. It a broad ecosystem, the smart integration. Okay, purpose device monitoring and automation of things. Okay, generate an intelligent insight and action. Okay, technology system, IoT, AI, big data, cloud analytics. Okay, outcome basic automation things and smart decision making and full integration. Okay, example smart bulb, wearable, smart meter, smart cities, automated industries, connected. This one example of IoT application is smart cities. So traffic optimization using sensor data and people inputs. Okay, smart street light, adapt human environment, connected healthcare, wearable hospital system, doctor analytics, smart diagnosis and personalized treatment, smart retail, automated checkout, Amazon Go style. Okay, personalized offer based use the decision industry for machine worker, big data and fully automation and manufacturing process. So conclusion, IoE is more advanced and intelligent and integrated version of IoT, and it brings more device and data. So in conclusion, IoE is more advanced, intelligent, and integrated version of IoT. It brings together the device, data, people, and process to create a high-value, smart, automated ecosystem. Okay. So an example: smart cities to smart city to mm, industry, industry to healthcare, healthcare to vehicle. Okay. Protocol and working on the Zigbees. Okay. So Zigbee is a low power. So Zigbee is a low power and low data rate, short range wireless communication based on the IEEE standard of something. Okay, 802.1.15.4. Okay, it mainly used in IoTs, smart home automation and sensor networks. Okay, Zigbee is a low power, low data rate, short range wireless communication protocol based on this. It is mainly used in IoTs, smart home automation and sensor network. Okay. So Zigbee protocol stack. Zigbee protocol stack is built on the top of this one standard and consists of the four layer. Zigbee protocol is built on the top of IEEE standard 802.15.4 standard and consists of four main layer. So physical layer, okay, based on IEEE standard responsible for the modulation, data transmission and receiving the RF signal. Operate in 2.4 frequency. Okay, handle the energy detection, channel clear channel assessment, channel selection. Okay, all these things. Mac is also based on IEEE manage access the wireless channel using CSMA. Okay, CA. मतलब carrier sense multiple access, and the collision avoidance. Okay, handle the frame validation. Okay, and acknowledge beacons management and association deassociation. Okay, after that, a network layer responsible for the network formation and routing things, support star tree mesh topology, perform address assignment, route discovery and maintenance, joining and leaving, and security management. Okay. In application layer, the topmost part of the Zigbee stacks, in which three part is the application support, manage of binding between the devices, help to discover the other devices. Zigbee device object manage the device role, Zigbee manage the device role, coordinator, router, or end devices. Okay, responsible for network discovery, security policy. So the actual end user define the actual defined user, smart bulb control and temperature sensor. Okay, so different type of Zigbee device types. So mm, Zigbee coordinators, one per network, form the network and assign the address. One per network, form the network and assign the address. Okay, Zigbee routers forward packet and extend the network coverage. Forward packet and extend the network. Zigbee and device. Zigbee sensor actuator. Low power sensor actuator route cannot route packets. Sleep to save energy. Okay, how Zigbee works. Network functional coordinator select a channel and a PAN ID and form a Zigbee network. So coordinator select a channel and PAN ID and form a Zigbee network. Okay. Device joining, how Zigbee work. So network formation, the coordinator select a channel and PAN ID and form a Zigbee network. Okay. Device joining, device scan the channel, they request to join the network through the association. Okay. Coordinator or router assign 16 slot address. Okay. Routing tree, routing start topology communication. The data transmission, device use CSMA to access the channel. For security, Zigbee use AES 128 encryption. Network keys, application level encryption. Low power on operation, so end devices sleep most of the time. Ideal for the battery. Okay. Coordinator router main active. So feature of Zigbee is low power, low battery, okay, support hundreds of nodes, okay, reliable mesh networking, cost effective and secure communication, okay. So conclusion, Zigbee provide a simple, reliable and energy efficient wireless communication solution. Use the layer protocol stack, support mesh network, ideal for the smart home and IoTs. So MQTT, MQTT in detail. So MQTT is a message queuing telemetry transport, is a lightweight publish subscribe messaging publish subscribe messaging protocol designed for the low power and low bandwidth and unreliable network. It is widely used in IoTs, sensor network, home automation, and the real-time communication. Okay. So message queuing telemetry transport is a lightweight publish subscribe messaging protocol designed for the low power, bandwidth, and unreliable network. It is widely used in IoT, sensor networks, and home automation for the real-time communication. Okay, the key characteristic of MQTT. So lightweight, very small, header size 2 byte. Okay, publish subscribe architecture, work efficiently on the low bandwidth network, high latency network, unstable connection. Okay, MQTT protocols. So it is a lightweight publish subscribe messaging protocol designed for the low power, low bandwidth. It lightweight publish subscribe architecture, work on efficiently on the low bandwidth network, high latency network, unstable connection. Okay, ideal constraint devices, sensor and embedded system operate over TCP and IPs. Okay, MQTT architecture. So MQTT architecture has two main components: broker and the client. MQTT broker, central server that manage all the message, responsible for receiving the message from the publisher. Okay, filtering the message and delivering the message to appropriate subscriber. Okay, example: Mosquito, Hive, MQ, EMQX. Okay, the two main component, the MQTT architecture is the two main component: central server, a central server that manage all the message, responsible for receiving the message from the central server, responsible for the receiving the message from the publisher, filtering this message, delivering the message to the appropriate subscriber. Okay, MQTT client. So client and publisher send the data to broker and subscriber receive the data from the broker. Okay, both are called client because they connect to the brokers. Okay, how MQTT works step by step. Okay, the connection established, client send a connect packet to broker respond, connect acknowledge, connection acknowledge, publish and publish subscribe process. So publisher send a data topic using publish. So publisher send send a data to the topic using publish, and subscriber register the interest in topic using subscribe, and broker deliver message to the all subscriber of that topic. Topic are the virtual channel for the messaging routing. Okay, for example, home slash living room temperature message delivery. Broker forward message to all connected subscriber. Okay, disconnection. So gracefully disconnected by disconnect packet. The quality of services level. So MQTT provide a three quality of services level to guarantee the message delivery. Quality of services 0, at most once. No acknowledge, faster but unreliable. QS1, at least once. Delivery is granted but duplicate may occur. QS2, exactly once. Most reliable, no duplicate but slower due to the four step handshake. Okay, no duplicate but slower due to the four-step handshake. Okay, MQTT control packet. So there are 14 control packet: acknowledge, publish, subscribe, acknowledge, unsubscribe, acknowledge, ping request, ping response, disconnect. These are the MQTT control packet. Okay. Okay. So MQTT features lightweight overhead, support written message, will send, persistence, non-persistent session, secure communication using TLS and SSL. Okay. Application of the MQTT: smart home, industrial IoT, healthcare and monitor, vehicle and telemetric, all these things. Conclusion: MQTT is a simpler and efficient. MQTT MQTT is a simple, efficient, and reliable protocol ideal for the IoT system with the low bandwidth and resource constraint. It is a publish subscribe architecture and QoS level make it perfect for the real-time scalable. QoS are so three type of QoS at most one. So no acknowledge, faster but unreliable. QoS one, at least once delivery is guaranteed but duplicate may occur. QoS two, exactly once, most reliable, no duplicate but simpler due to the four-way handshake, four-step handshake. Okay, so NB IoT, narrowband IoT, narrowband IoT. Narrowband Internet of Things is a low power wide area network. Low power wide area network technology developed by the 3GPP. NB IoT means narrowband IoT. Narrowband Internet of Things is a low power wide area network technology developed by the 3GPP for connecting a large number of low power and low cost devices over the long distance. So simply when we have to explain NB IoT, this is a narrow band Internet of Things. It is a low power wide area network technology that is developed by 3GPP for connecting the large number of low power and low cost IoT devices over the long distance. Okay, it use cellular network and require very low bandwidth. Okay, it is a cellular network and require very low bandwidth of 182 kilohertz. Okay, the key feature of NBQT: so narrow bandwidth, okay, low power consumption, long range coverage, massive device support, low cost and license spectrum. So as the name suggested, NB, narrow bandwidth, means it has a bandwidth of 180 kilohertz, a very small channel. Low power consumption, battery life is up to 10 year. Low power consumption, the battery life is up to 10 year. Long range coverage मतलब across different battery, sorry, low range coverage works deep indoor and rural areas. Okay, massive device support mean that up to 50,000 device per cell, up to 50,000 device per cell. Low cost, simplified RF module and low data rate, okay. License spectrum, secure and interference free. License secure and interference free. Okay, this is key feature of the NBQT. Okay, after that we have to look at NB-IoT development mode. So NB-IoT can be developed in three modes: in band, guard band, standalone. So in band, use existing LTE carrier. So in band, use existing LTE carrier, share a spectrum with the LTE. Okay, use existing LTE carrier, share spectrum with LTE. Guard band, this one, utilize unused LTE guard band frequency. Okay, utilized unused LTE guard band frequency. Standalone, reform old GSM band for the NB IoT. Reform old GSM band for the reform old GSM band for NB IoT. Okay, these are the NB IoT, the narrow band IoT development modes: in band, guard band, standalone. In band, existing use, guard band mean utilize the unused LT or reuse, reform. NB IoT architecture. NB IoT use simplified cellular architecture including UE, user equipment low power NB IoT sensor, okay, smart meter. E node B, base station supporting IoT data. G node B, okay, E node B or G node, base station supporting NB IoT radio frequency. User equipment, low power NB IoT sensor devices. E node, base station supporting NB IoT radio. EPC, मतलब evolved packet core, evolved packet core, 5G core. Manage authentication, mobility and data routing. Manage authentication, mobility and data routing. NB IoT work. Device registration, attach a barrier setup, data transmission, power saving technique and coverage enhancement. Okay. First of all, how it works? First of all, how it works? Device registration. So device connect to the nearest NB IoT base station and authentication using SIM and eSIM. Okay. Device connected to the nearest NB IoT base station and authentication using SIM and eSIM. Attach and barrier setup. So device establish a low power data barrier with minimal overhead. So device establish a low power data barrier with minimal overhead. So attach a barrier setup. Device establish a low power data barrier with the minimal overhead. Data transmission. Use small infrequent packet. Use small and infrequent packet. Uplink rate will be itna, downlink rate will be 20 to 60, 30, 70. Power saving technique. NB IoT use 3GPP power saving feature. Okay. PSM, power saving mode, and device sleep for hours a day. Okay. Extendable and discontinuous reception. Lower the frequency of listening to the network message. Okay. RRC, ideal and connected mode, efficient signaling. Coverage enhancement, repetition of the packet for the strong coverage. Work deep underground basement parking areas. Extremely low power, long range, deeper inside penetration, uh, very low cost, secure connection, support massive IoT deployment. NB IoT limitation, low data rate, okay, high latency as compared to LTE. Mobility support is limited. Okay. Application of NB-QT, NB-IoT is that smart metering, gas, water, spending periodic data. Okay. Smart cities, street light, waste management, agriculture, soil sensors, healthcare, all these things. So NB-QT, NB-IoT is a low cost, low power, long range cellular technology ideal for the massive IoT deployment. Okay. It is excellent coverage for the long battery life, make it suitable for the smart cities, industrial IT and utility monitoring. Okay.